Hi everyone, welcome back. We're going to continue with the final exam review, and this week will be a final exam review week. I will be posting new videos every day, starting today, all the way through Friday. So make sure that you come back to the channel to check out those videos, to make sure that you go through all the examples that I go through that may help you with your final exam review. All right, let's get on with it. We're going to continue with the final exam review. This is Pre-Calculus 12, the two topics of exponentials and logarithmic functions and equations. But we're going to start with very basic expressions, simple exponential expressions and logarithmic expression, and then we're going to move into solving exponential equations and logarithmic equations. Heads up, this video is going to be a little bit longer, so it's going to be around 15 minutes, so hang in there. Let's get on with it. All right, the first question, simplify. This is exponent laws, so we just have to go through exponent laws and simplify this expression. And I'm assuming that you remember all of your exponent laws, so let's go ahead and do this. So this is the compound exponents, exponent of exponents, so power of power. So we're just going to go through and we do one terms at a time. Okay, we're going to start with x squared. So here you go, x squared here, x squared to the power of negative half, then y to the negative half, negative 1 to the power of negative half, and then we're going to do the same thing with the second term, okay, or second expression. So let's go ahead and do this. So x squared to the power of negative half, then y negative 1 to the power of negative half, okay? Then we're going to do the same thing to the other one. So x to the negative 3 to the power of half and y to the power of half. Okay, that's all we have. Now we're going to go simplify. So we have x to the power of, remember, power of a power, you multiply the exponent. So this would be negative 1. And then y, negative 1 times negative half, so just going to be positive half. So it's a multiplication. Next one, x to the power of negative 3 half. We're still multiplying the exponents. And the last piece, y to the power of half, which is itself. All right, now last step, same base, x and x, same bases. We add the exponents, so as the y's. Y and y the same, we add the exponents. So negative 1, so we're going to start with the x. So x to the power of negative 1 plus negative 3 half. So negative 2 over 2 minus 3 over 2, and that would be negative 5 over 2. Okay, so that's the exponent for x. And then y will be y to the half, half plus a half is 1. Okay, so this is the final answer. Now, one step further you can go ahead and do, you can change this exponent, which is negative, to a positive exponent by using the reciprocal. So reciprocal rule. So 1 over x to the power of 5 over 2, and then times y, or you can just put the y on top and then don't put the 1 in there. So this is leaving your answer with a positive exponent, but the top one right here, that's also an answer, but it's not fully simplified. Excellent. Now let's move on to the next question. So we're going to use log laws. These are additions and subtractions when you have the arguments that is multiplying or dividing. So here it is, we're going to do one thing at a time. We're going to start with the top first. So this would be log of a squared plus log of b. Okay. Now all of that, then you say minus log of root c. Okay, I'm going to deal with that, but we cannot leave argument as a square root. Everything has to be simplified the most possible way. So next step, this one, log of a squared, is 2 log of a plus log of b. Log of b cannot be simplified, so that's what that is. And then the last piece is that negative log of c to the half. We are changing the square root of c as exponential form instead of a radical form, and that becomes c to the 1 over 2, or to the exponent of that. And then the last step is, I just added one more step. So 2 log of a plus log of b minus 1/2 log of c. Now in this question, I've been using the addition, subtraction, and the power law for the log. So 3 rules we have used, including changing the square root form to the exponential form, okay? And most simplified form of that expression. Very nice. Now let's go ahead and look at question number 3. Okay, remember that whenever you are dealing with the exponential equation, we need to use a tool, the tool of logarithms. That's the easiest way to do that. There's another way of doing this. We're using it graphically. If you want to graph the two functions, the right function and the left function, you have to graph y equal to 5 to the 1 minus x, and the other one is 2 to the 1 minus x, and then look at the point of intersection of the two exponential graphs. That's definitely a legitimate way of doing that, but that will take a little bit longer. And plus, it has to be very accurate, and unless you're using some kind of a tools, graphing tools, you may not get the exact answer. You have to, again, do the estimation. We don't want that. We want an exact answer here. So let's go ahead and use logarithms to solve this exponential equation. First thing, we're going to take the log of both sides. So here it is, log of 5 to the 1 minus x equals to log of 2 to the 1 minus x. That's the first step. We take the log of both sides. We're not doing anything illegal mathematically. Next thing, we're going to use the power law of the log. So that means the 1 minus x, the exponent comes to the front of the log expression. So that becomes, open a bracket, that's equal to 1 minus x log of 5 equals to, we're going to do the same thing to the right hand side, 1 minus x log of 2. Okay, now we're going to do the distributive law. We're going to use that, multiply each term by log 5 on the left hand side. So we're going to get log of 5 minus x log of 5 equals, and then we're going to do the same thing to the right hand side. That would be 1 times log of 2 is log of 2 minus x times log of 2 is x log 2. Fantastic. Now we're going to collect like terms. Now, when I say like terms, that means all the x's on one side and all the non-x terms on the other side. You choose which one, left or right, but I'm going to put x's on the left in this case and numbers on the other side. So here it is. So we have, I'm going to add x log 2 to the left hand side, and I'm going to subtract log 5 from both sides. Okay, so adding x log 2 to both sides and subtracting log 5 from both sides. So what are we going to have? We're going to get final answer, or simplified answer is, we get on this side, we're going to get negative x log 5 plus x log 2 equals log 2 minus log 5, and then minus x log 2 plus x log 2, that's just 0. All right, so we're almost there. Last step, we're going to factor x out. We get x out, we get negative log of 5 plus log of 2 equals to log of 2 minus log of 5. Now we're going to divide both sides of the equation by the coefficient of x. Now, the coefficient of x, even though I wrote this term minus log 5 plus log 2 to the other side, on the side of the x, but it's actually a coefficient of x because that's actually a number, okay? That's just going to numerical value when we use the calculator. But we're going to leave it the way it is. So we're going to divide both sides by negative log of 5 plus log of 2, and same thing the other side. So what will happen is that that divides as 1. So the final answer here, x, is log 2 minus log 5 all over log 2 minus log 5. And notice what I just did. I switched the log 2 and negative log 5. I switched the order. So I could actually write this. I just want to make sure that you see that. You see this is right there. That's log 5, negative log 5, and that's log 2. So these two statements are identical to each other. All right, instead of writing negative log 5 plus log 2, I put down log 2 minus log 5 is identical. And look what is happening. The top, the numerator of this fraction, it says log 2 minus log 5. The denominator says log 2 minus log 5. So what's going to happen? You divide. And when you divide, what do you get? You get 1. So the final answer is x equals to 1. Now, go ahead and you check your answer. When you check your answer, what do you get? When x is 1, you plug it back into the original equation. You get 5 to the 1 minus 1, that is 0, equals to 2 to the 1 minus 1, that is 0. Is 5 to the 0 equal to 2 to the 0? Sure it is. They're both equal to 1. This is a logarithmic equation. The question is solving for x. All right, we're going to use log laws here. We're going to simplify. We're going to use log laws. So let's rewrite first. First of all, we know that log of 100 is 2. We just know that because 10 squared is 2. So we're going to change log of 100. This value is 2. So we know that 2 log x minus 1 equals to 2 plus 2, which is equal to 4. So that's perfect. Now we have an easier equation to deal with. So 2 log of x minus 1 equals to 4. Now, next step is this 2, we're going to bring it up. We're going to use the exponent law or the power law of the log. So this is actually log of x minus 1 squared, that's equal to 4. Okay, so remember that law again, right? So if this was given to you like this, log of x minus 1 squared, well, you just bring the 2 to the front. That's how you actually simplify it that way. All right, now next step. The next step is tricky. Okay, now you have to rewrite this statement, this logarithmic equation, in exponential form. And how do you do that? Remember, if the base of a log is not given to you, this means the base is 10, right? So let's rewrite that, rewrite it as an exponential. I am going to make sure that I'm just going to put 10 in down here just for the reminder. All right, so this expression is equivalent to 10 to the 4, 10 to the 4 equals the argument of the log, x minus 1 squared. Okay, simple as that. That's the question. Now we have a quadratic equation to solve. And then in this case, what I will do is that I want you guys to go ahead and solve it because this is just a quadratic equation. You expand the other side, or you can just go ahead and do it right away. That doesn't really matter. But in this case, the best thing to do is take the square root of both sides. You get 10 squared is equal to x minus 1. So x is equal to 10 squared plus 1, which is equal to 101. Okay, now check your answer. Okay, original, very original equation. So we have to take this 101, x is 101. Okay, so this is value of x. Just making sure you know that. 101 is the value of x. We're going to take that and we're going to plug it back into the original equation for x in the log equation. And let's see if the left-hand side is equal to right-hand side. Okay, so that's what we're going to do. We're going to check 2 log of, this is 101 minus 1. Is that equal to basically 4? So is 2, and this is log of 100, right? So that's 100. 2 log of 100, that means 2 times log of 100. Log of 100 is 2. Is 2 times 2 equals to 4? Sure it is. Sure it is. Fantastic. Okay, so we used log laws in this case to break it apart, and then we just use this technique of taking the square root of both sides, taking the square root like that, square root of both sides. Remember, that's how you actually solve quadratics or anything that's got to do quadratic or powers, right? So you can take the square root of both sides because we want to get the value of x. We don't want x squared, okay? Now, there's another way of doing this question, by the way. Another way is that you expand x minus 1 squared and then subtract away 10 to the fourth out from that. Then that becomes a quadratic equation. And then what you would do is that you just plug into a quadratic formula if you want to, or factoring, and then solve it that way. That's another way of doing it, and that's no problem. But that one is a little bit longer, okay? You need to add 2 or 3 more steps to that, but this is fast. All right, I hope you found this useful. Remember, reviewing for final exam, how would you review that? You have to go through your notes, but don't forget, the first thing you have to do, you have to organize your work unit at a time, section within the units. Once you have it, then you go through each of those questions and take those questions from quizzes and the unit tests and go over those concepts. And if you forget, you keep going back, referring to the notes that you got from your teachers, and then you practice, practice, practice. All right, keep at it, be well. I will be posting more questions throughout this week every day. I will be doing that for different classes as well. So please make sure you come back and check so that you can see new questions for you to do and review. Keep at it. Be well.